Hello friends, in this video I will going to discuss about one of the sorting algorithm, that is insertion sort algorithm, which takes time complexity of, in worst case scenario, big of n square, and in best case scenario, big of n. So basically insertion sort algorithm is one and only one algorithm which take best case scenario big of n algorithm sorting time. It is also in place, that means it doesn't take extra space to swap or to change the position of the array elements. It is also stable. Stable means when there are copied elements, for example there are 320 elements, 20 20 20, there are 3 times 20, then the first index which occupy that first 20 will occur always first. That is called a stable algorithm. And last is used for practice in small arrays. Basically, when array size is small, it is feasible to use the insertion sort algorithm because it takes a very less time. Also interesting fact about insertion sort is that in Python library there is a inbuilt function tim sort. In that tim sort, basically it is the combination of merge sort and insertion sort. Whenever the file size is large or very large in size of array, then automatically merge sort will perform that particular sorting and gives output in console. And when the file size is less, then the insertion sort come into picture and it performs as the operation of sorting. So that's a fact. And also in screen there are 6 element of array, that is 25, 40, 60, 10 and 30. So it, what it does actually, it first take the first element and sorted that, and if there is a no comparison, first element is always sorted. So whenever we write to code this insertion sort, we have to take care that we have to start from the second element, that is from 5, ith index is from 1, and then afterwards it compares us two elements, first two elements, that is 5 and 20, and 20 is greater and 5 is less, so it is remain in its original position. Then come to 40. When 40 is compared with 20, 20 is less and 5 is also less, so then again they are in their original position. When it compares to 60 again, that is next iterative call, then all these elements are already sorted. But when it comes to 10, 10 have a space before 20 and after 5. So I index is come to 10 and j index traces back to the first index and it places that particular 10 into that position. That's how insertion sort work. It first iteratively go through all the elements, check how whether it is its original position or not, and then come back to the position where it has to be in that array. That's the algorithm of insertion sort. When we code it, you shall see more easily that how the I and j indices have been work here. So first void is insertion sort. We have to take one array and we have to take the size of the array, which is n. Two parameters, first is array and second is size of array. Then we have to take for loop I is equal to 0 to pass through the each and every element. We take first for loop. Then we have to take a key which store the ith element of array. Every time ith index will move forward, and that particular ith index element we have to store in key so as to compare with the other elements. That's why we store in the key. And we require another variable which is j, which is I minus 1, and we have to compare that if j is greater than equal to 0 and array of j is greater than key. If these two conditions satisfy, then array of j plus 1 we have to store into array of j. That means we have to, if the while condition is for that, if j is greater than 0, that means j is not going back in such a way that it gets into negative value, because array indices are all positive starting from 0. So that's why this is crucial condition. Second condition is array of j is greater than key. That means the element which I'm iteratively go through is greater than my key. So my key should be less, but it is happening reverse. So I have to change that array of j plus 1 to array of j. We have to shift that array of jth element to array of j plus 1. We have to move forward plus 1, and we have to trace back that j backward. And after doing so, each time we have to compare, means for example j is 3 and I is suppose 4. So a of 4 is some value, that is a of 4 is 40, and a of j is suppose 60. So array of j is greater than key. That means the array is not sorted, it is unsorted, it is showing decrease in order. So in that case, we have to increment that number to the next position, and we have to decrement my index position in such a way, after going through comparing through each and every index, we have to fix into that index where that particular element is originally positioned. So for that we have to use here j plus 1 and is equal to key. That's it. So it fixes our key to the position where it should be. It should be in that position always. Then and then our array is sorted. So this is code, and we have to take array to check that. We have to take 6 element, 25, 40, 60, 10, 30. 25, 20, 60, 10, 30. That's it. These are the 6 elements. Then insertion sort array comma 6. After calling this function, this is passed by reference, so all our array elements are sorted now after calling this function. So we have to check just that our array is successfully sorted or not. For that we have to use a loop. So that's it, code is done. So we have to check the output if it is getting or not, or we have to debug it. Now just wait for a minute. So as you see on the screen, the array elements which were first in 25, 20, 60, 10 and 30, they are sorted now, and the answer is 5, 10, 20, 20, 30, 60. Means array now are in increasing order, means they are sorted. So this is insertion sort algorithm with time complexity big of n square and big of n respectively. That's it. Thank you for all. Stay blessed.